So we've sort of come to the end of this chapter, and we're going to discuss anomaly detection. I don't know, maybe I'll add a bonus video just to discuss the unsupervised deep learning algorithms. I know I mentioned them in the beginning, but there are some parts that I really want to discuss that would be very influential in this course. Those ones, they are very little. So, but I might just add it as a bonus video to this after this video here, the anomaly detection one. And this is going to be a quick one because we have already discussed methods that are used in anomaly detection. So I'll just call this, I think this is 4 now. And then, so the order has changed a bit. Anomaly detection, our unsupervised algorithms. Unsupervised algorithms, right? So what happens with these ones is we can create a lower dimensional space using dimensional reduction algorithms, right? And our points are going to be in sort of like a similar space, maybe. You remember when we did t-SNE, right? t-SNE, they sort of were in a similar spot. The ones that were similar, they were in a similar area, sort of, when we moved from high dimension to low dimension. And that similar space, or that area there, is called the normal space. The normal space. And points that lie further away from the normal space, these are called outliers or anomalies. They are called outliers or anomalies. And these anomalies, sometimes they are worth investigating. Why is it outside our normal space that we expect? Why is it right out there when we brought it down to lower dimension? So essentially what I've just alluding to is you can use dimension reduction techniques to figure out what your anomalies are. So after you've done dimension reduction techniques, you can do clustering. So let me just write that process down. You can do dimension reduction techniques, dimension reduction, and then you do clustering. You come up with these clusters that make up like your normal space, and then after that you then look at which ones are not part of those clusters. These are your anomalies. Then you look at these anomalies, like, why are you an anomaly? Person number 20, person with the ID number 20, why are you an anomaly? You try to analyze why the person is an anomaly. It's different from everyone else. So here, these ones, let me just write a few examples of where they are used. So this we've already discussed, dimension reduction. We've discussed clustering. So there's no need for us to discuss like the actual algorithms themselves. We can discuss where they are used. They are used in fraud detection. So whether it's going to be fraud detection, so it's going to be whether it's card fraud, credit card fraud, it's going to be your cyber fraud, let's say on online banking or whatever it is. So they're used in fraud detection, whether it's that or insurance fraud, right? Wire fraud, any of those. They help us identify rare events or rare instances. So let's say our computer is being hacked. This algorithm knows what is normal in our normal space. Because of a hack, our server is now experiencing traffic that is an anomaly. Because it is an anomaly, it will be like, this is not normal. And then it can alert us that something is happening. So hacking, you can use anomaly detection when you analyze the traffic. And then you can do something like also like maintenance. Is this the spelling of maintenance? How do you spell maintenance? Is it N-A-E? I'm not an English person, guys, so I don't know. Just know that we're doing maintenance detection or maintenance failures. We are detecting the failures. So we know our machine. We know our machine, our drilling machine, whatever it is going to be. We know how it operates. We know the parameters it operates in, the temperature, the pressure it experiences and stuff like that. If it starts exhibiting things that are not, or like over days, it starts experiencing stuff that is outside the normal space, maybe it is now hitting too quickly. It is experiencing too much pressure. It is about to break. So maintenance failures is another use case. Another one is going to be the one that we discussed, spam detection. We know the emails that we receive. We know how often, we know the IP addresses, where they come from and stuff like that. An anomaly will be an email that is outside the cluster of those normal emails. Then we also have things like you can catch out bad actors that are doing terrorist funding. You can use anomaly detection to catch out terrorist funding. All of a sudden, they are sending money to some country they never used to send to, or people that they never used to send to. What is really going on here? These large amounts, they are now moving through too many channels, and we do not understand. The money laundering. Money laundering is another good one, where you can use anomaly detection. Money laundering. Human trafficking. Human trafficking. When you do not expect people to come from a certain country with a certain age and stuff like that, it's like, why are we experiencing now, all of a sudden, these many people coming to our country from this particular region that we never saw people, especially of this particular age, with these particular people? It can fall outside the normal space when you cluster the visits, when you cluster visitors based on their attributes. When you cluster them, they'll be like, yeah, they are here. So inside there could be a cluster for tourists, a cluster for people, for business people, a cluster for retainees, right? A cluster for asylum seekers and stuff. But all of a sudden, there's now just this anomaly that is way out there. Those could be like detected like that. You can do arms dealing. You can catch out arms dealing using anomaly detection. You can also catch out like diseases. Onset of diseases like cancer. When you look at a person's medical history, or medical points or data points when it comes to their medical measurements, right? And then you start seeing that there's something that is changing when you cluster all the other stuff. When you cluster things, all the other measurements, you see that there's now an anomaly or a measurement that is just way out there. You can catch out diseases like cancer. So anomaly detection is very, very powerful. And I'm not saying for the anomalies you have to get rid of them. The important part is investigate them. I think I emphasized that when I talked about outliers in a previous video. Investigating them is very, very important. Don't just get rid of them like, you're an anomaly, I don't want to deal with you. No, you can't do that. You have to investigate it, because it could be a data point that that is showing you that you're working for a bank. There could be some terrorist funding going on when you investigate it. So this anomaly detection, it can so as you can see, when I'm saying investigating, it means you can put a system in place that then triggers when it finds anomalies. It sends you an email that it has found an anomaly. It is detecting an anomaly. When it's detecting that anomaly, you then log in to your system, and then you check, why is it finding that anomaly? Which ID is an anomaly? Oh, it's this ID. Why is this person now giving me as an anomaly? And then you investigate their transactions, you investigate everything. Who is he connected to? You might actually find that this person is involved in terrorist funding, for example. Very, very out there use case, but yeah, I think you understand the power of anomaly detection and the power for it to stop very hectic stuff. So this is the end of this chapter. In this chapter, we're just looking at the very, very high levels of unsupervised learning algorithms in the different use cases. So we did dimension reduction, right? And our use cases was to say, how do we improve on supervised learning? We have a supervised learning system. How do we improve on it? We can improve on it by using dimension reduction techniques. That's what we did. We said dimension reduction techniques can help us improve on our supervised learning model. And then we went on to say we can use Clustering, if we cluster first before we get into supervised learning, it can help. We also looked at if we use feature extraction on supervised algorithms, we can come up with better features that will help our supervised learning model. And then now we just looked at anomaly detection. We said if we detect some anomalies before we get to our supervised learning model, we can deal with the anomalies on the side. And put a supervised learning model for our normal space. For our normal space, we can put our supervised learning model. But for the anomalies, we can investigate them further on the side. So that is what we're doing in this chapter. In the next chapter, what we're going to look at is we're going to look at a supervised learning model, because this is the structure of the course. We first started with the supervised, and then we said these are the challenges that data scientists are going to face. We use these algorithms, this is unsupervised, to improve on it. Now going forward, we are going to see how that actually works. In the next chapter, we are going to look at a supervised learning model, a project. And then in the chapters following that, we are going to look at these. How do we use these unsupervised to improve on that? On that model we would have built in the next chapter. So let's meet each other there. And for next chapter, we are going to include some Python coding. I'm not going to code it live on a video. I'm just going to paste the coding. I'm just going to show you the codes, discuss parts that make sense, but I'll put a link to the GitHub where you can go through the coding. I just want to talk about the principles and their explanations behind what we'll be doing. So we'll meet in the next video.